live. Okay, so here we go. Today we're going to do a tide or a application with a sine curve. So 5, 13, 19. So again, Bill and Lana were sitting on the dock of the bay just watching the tide roll away. As they sat there, they noticed the tide was high at midnight. So let's just go midnight at a height of 2. So I can put a point right there. That makes sense, right? Midnight there. So then if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's noon, okay? There's my noon. 1, 2, 3. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's midnight again, okay? So I went to noon, right? And then if you do military time, which is actually a little bit easier because you don't want to go from 12 and start back at 1. That seems silly on a graph, doesn't it? If counting to 12, you wouldn't go back to 1. So let's just call it 13. And military time, 13 would be 1 o'clock, okay? Right? That means like 18 would be 6 o'clock, right? And Ledger's going to stop talking so that way Gavin can learn, right? Yeah, so sure. I know that that we had a low tide at 8:30 a.m. So 6, 7, 8. That's 8. That's 9. So 8:30 would have a low tide right there. Okay. All right. That's all we have. So first of all, when's the next high tide? Well, that's not too hard. It seems like we went 8.5 hours, right? So if we go another 8.5 hours, so I know that a half tide from high tide to low tide was 8.5 hours, right? Sure. I can just read it. Midnight to 8:30, right? So then, provided that our tide's going to stay constant over a couple of days, at least a few hours, that the next high tide would be another 8.5 hours, right? So then from low tide to my next high tide is going to be another 8.5 hours, okay? So really, if you add the two, that's like 17 total hours, right? So if I count my 12, 13, 14, 15, 16, 17, that's where my next high tide is. Now 17 would be the same as 1, 2, 3, 4, 5 o'clock p.m. So we've got either military time. We can go, okay, military time 1700 or 1700 in military time, or we could say it's the same thing as 5 o'clock p.m. Not bad, huh? Okay, let me go ahead and sketch it in. Sketch it in. Of course, it's going to keep going and going and going, okay? Now, find an equation to model this. Now, let me see. I've got to get out my notes. I've got to look at my graphs to see, okay, which one is it, right? Yeah, it's a cosine, isn't it? So it's either, to do an equation, let's go on the side. I know the sine curve looks like this. That's a y equals some sine of theta. Or a cosine curve looks like this. Y equals some cosine of theta, okay? Well, it's got to be a cosine. Now, how do I know that? I know where it starts, right? So it starts up. It doesn't start at 0, right? It starts up, and cosine starts up. So let's call it a cosine wave instead of a sine wave, right? So I'm going to start off with y equals, and I'm going to make it a 2 cosine of something, okay? Now, that makes sense to me, 2 because it has an amplitude of 2, because of the tide. Cosine curve because it starts at a height of 2, right? Then, the next thing is, how do I get this number in here, okay? This is called the frequency. This is B, this number here, and B is called, so Bx, or in this case we'll go Bt. You guys okay with the variable t for time? B is the frequency. What the frequency is yeah, so what you do is you take your 2 pi, so B is again our 2 pi divided by our curve width. So for us, it's going to be 2 pi divided by 17, and that's our frequency, okay? So our frequency is 2 pi over 17. So you just take 2 pi, which is the standard width, okay, standard width, and you just divide it by the width of the curve. So we're going to rewrite this as y equals 2, and I can go then cosine of 2 pi over 17 t for time. Okay, that's my equation right there. And I'll stop and let you think about it, okay? I'll stop and let you think about it, okay? So I took 2 pi, okay, and I said, okay, my normal curve has got to, in a sense, it's got to be divided up by 17 because that's how long the curve is, all right? Now, what's the height at noon? Okay, so I could guess at noon, let's see. It's right about there. It's about -1, but that's a guess. So what I'm going to use is my equation. Let's see, I'm going to let t equal 12, because that's noon, right? I'm going to plug it in. So I'm going to go, okay, I'm going to go y equals 2 cosine of 2 pi over 17 times 12, and I should get the answer. But I got to be super careful. First of all, degrees are for dummies. We're not in degrees. In fact, I know we're in radians because our circle that we created this graph from is in radians. I know that because of the 2 pi, right? So I must be in radians. Does that make sense why I'm in radians? When I did my unit circle and when I did my curve, I did it in terms of radians. You guys agree with that? So if you don't change your mode to radian mode, you're going to type everything in correctly and get the wrong answer. So before I do anything, got to do radian mode, okay? Radian mode, so I'm going to go ahead, I'm going to highlight that. Please highlight that, okay? Radian mode. Of course, we're going to mess up my NICS classes because they're doing right triangle trig, so they're really going to be messed up if you guys don't put it back, but oh well, right? So I'm going to go ahead and go back to my mode, okay? I'm going to make sure I put it in radian mode, right? And then I'm going to type in 2 cosine of 2 pi divided by 17 times 12. Let's see what I get. About -0.55, really, if I want to be pretty darn accurate. So the height of the tide would be about, my height would be about -0.55 meters. That's not that bad of a problem, is it? It's not that bad. You guys can do that? Okay. Okay, and that's all I have because I wanted to spend most of the time today